Good morning, dear students. Very good morning. Namaste. I am CS, sir, Maths CS. My name is Chandrasekhar. Welcome to Aryabatta College, Dharwad. Okay, my subject is mathematics, and I have been working in our college in Dharwad 5 years. And actually, I am from Andhra, from Tirupati. In reputed colleges, I worked nearly 30 years. This is 5 years, 35 years experienced person. It is my side introducing. Okay. Now, this is a bridge course for the mathematics. For your upcoming students from school level to college level, this is PU 1. Here I want to tell something. The bridge course is a very essential one. What is the need necessary to teach the bridge course? Means you learnt so many concepts in a particular subject. For example, my subject is mathematics. So I want to tell about the mathematics. You learnt in your previous classes, that is 7, 8, 10th, 9, 10, like that, up to school level. You learned so many concepts, but there you may concentrate on how to secure the marks. Even the teachers and the school management also, they are not imposing you that, not force you to learn a deep study. How to secure the marks, how to solve the problems. There your masters may, the previous time I am telling, they use that concept, that formula in order to solve the problem. Only that one. And after that completion of that particular concept or particular chapter in the mathematics, you simply leave that one. It is common, not only for you I am telling. It is common everywhere, the student is like that. We learned so many concepts in the 8th class. And we will come to the 9th class. Then we forgot all those concepts. Simply we forgot. When time comes, okay, we will verify that one and we will use it in solving the problems. Yes, okay, it is okay. But here, in the PU1, here, all that concepts are needed. It is on and off, it will come while you are solving a problem. Here, you are coming to join in the PU1, is it not it? While we are, suppose we are talking about, we are teaching about, we are learning about the trigonometry. Trigonometry is a very good chapter. Or a calculus, or algebra, or matrices. So many different chapters are there. While we are concentrating, while we are learning that chapter, so many fundamental concepts are coming. Okay, now? At that time, it is not possible to tell about that particular concept. If you concentrate on that particular concept, which is called as a fundamental, the main chapter will go aside. Okay, now? For that purpose, in the bridge course, we recall. It is a very good terminology. We recall all those things. You see on that board, the fundamental concepts and the formulae. You know all these formulas. Is it right? I want to recall those one. And by recalling those concepts, you can concrete, you can take it in account in order to record in our mind forever. Okay, now? Not in the previous time. Here it is needed. It is needed. By force, you may learn this one. A plus b whole square is equal to a square plus 2ab plus b square. In the beginning stage, Say, for example, in 7th or in 8th classes, you know it. But there you are unable to apply that one. With a great effort, you are applying that one. But here, it is a very simple concepts in the human. Okay, na? You try to understand what I am telling them. That is that. What is the need of bridge course? It is a 5 or 6 classes. We will give this bridge course. For myself, as a senior lecturer, I am giving this bridge course for mathematics and for physics, chemistry, bio, all are there. We will complete it within a week. Afterwards, we will start actually this one. Okay, na? Yeah. Now, we'll come to follow the bridge course. As I said already, what is the meaning of a bridge course? Means it is a simple. The fundamental concepts already you dealt with. That will be recalled once again in order to make it familiar to us. Okay, na? Make it those concepts to be recorded in our mindset. Okay, na? Like that. Now, a plus b whole square. It is well known. A plus b whole square means a square plus b square plus 2ab. Yeah, it is well known. Not only for a and b, you take x plus y whole square means x square plus 2xy plus y square. A minus b whole square. It is also okay. A square minus 2ab plus b square. If minus is there, minus 2ab. Plus is there, plus 2ab. Even now, from you, not a particular you, from your group of students in the classroom. Why? Because with experience I am telling. A minus b whole square means they are putting here minus. A plus b whole square means here plus b square. A minus b whole square means they are putting minus here. It is a wrong concept. Isn't that? We have to learn it well. We have to by heart it well. It is to be recorded in our mindset permanently, not be erased like that. Okay, na? Minus b means here only minus 2ab. Plus b means plus 2ab. Okay, na? That is a plus b whole cube. Square is okay. Cube. A cube plus 3a square b plus 3ab square plus b cube. Okay, na? Plus is there, all are pluses. A cube first, then it is reduced a square, then it is reduced a power 1, then it is reduced a power 0. Here a power 0. A power 0 means 1. 1 into b cube is b cube. Whereas you see, in the first term, b power 0 is there. But here we are not mentioning. B power 1, b means b power 1, b square, b cube. Like that. It is somewhat difficult. Out of you, nearly, if you take 10 members, you only 1 or 2 members can give this answer. The remaining are having some doubt. Not that one. Not like that. We have to by heart it. Here it is needed. A plus b cube means a cube plus 3a square b plus 3a b square plus a b cube. Or otherwise, we may write this one as a cube plus this last one b cube plus 3ab of a plus b. This notation is used in higher studies. In lower classes, we use this formula. Of course, both are same. We are writing a cube plus b cube. In this second and third terms, 3ab is there. Here also 3ab is there. So 3ab is taken as a common. 3ab of here remained a. There remained b1. Okay na? Is it okay na? Here you see 3a. Another a is there. That a remained here. Here also 3a b into b. One more b is there. This one. Okay na? Like this we have to write the formulas in higher studies. A minus b whole cube. It is alternate. Plus a cube minus 3a square, same term, plus 3a b square, same term, minus b cube. Here all are pluses. Here minus comes means plus, minus, plus, minus. Okay, now like that. And here also we may mention a cube minus b cube minus 3ab. If you take minus 3ab as common, here a remained and minus b remained. Okay, now like that. Try to understand it. minus, if you take the minus as common, these two terms okay, a cube minus b cube is okay, minus 3ab, here in this term, second term, 3ab is there, in third term, 3ab is there, as usual. If 3ab is taken as common, okay, now here a is remained, here b is remained. But minus is in minus. Here it is a plus, becomes as a minus. Minus into minus, plus will come. In the mathematics, a keen observation. Everything must be seen by you, observe it well. Not as in the high school level. Here is somewhat typical and difficult concepts will be there. We have to maintain a keen observation while the master is going on the board. Each and every step written on the board, you have to take it down on your notes, and you have to see and observe it. What is there? What is going is there? And what I am uttering, what I am giving the lecture, what I am telling, all those things you have to listen it in a careful way. Okay? Yeah. You see, while we are applying, the students may commit some mistakes. While we are applying a minus b whole cube means, here it is a cube plus b cube, no problem, all are pluses. If minus is there, here is the problem. Here all pluses, here is all minus. You observe me, minus, minus, minus. Whereas the plus, plus, plus. With some notation, we have to remember, we have to make it as a recorded in a good way. With some notations. Okay. Now, this is fifth one. These are all simple. These are all very simple. In the previous classes, you may, not for all of you, many students are well versed with these formulas. But some are unable to follow. This is very important. Okay, first 4 is okay. Fifth one. If a plus b plus c is equal to 0, then a cube plus b cube plus c cube is equal to 3abc is directly it will come. The condition is a plus b plus c is equal to 0. It is given. In the problem itself, a plus b plus c is equal to 0. Then, what is the condition? Directly, a cube plus b cube plus c cube is equal to 3abc. How it is? Now you see. Today I will teach only 10 formulas. How can we observe it? This is we are in the fifth one. We are given, this is solution, fifth one, observe me. We are given a plus b plus c is equal to 0 now. This is given. That implies a plus b is equal to minus c. I am sending c to that side. Plus c, if it goes to RHS, it is minus. Minus c goes to that side, plus. Plus, minus, minus, plus. Into division, division into. Square root, root square will become. You know it well. So, plus c means it is going that side with the minus c. Now, cubing on both sides. We are cubing on both sides. That means a plus b whole cube is equal to minus c whole cube. Okay na? Is it okay na? What is a plus b whole cube? Already we know a formula. This formula, not this one. This formula. It is a cube plus 3a b cube plus 3ab of a plus b. I am mentioning the formula, not the first one. Both are same. Already I said it. A cube plus b cube plus 3ab of a plus b. That is to be mentioned. And minus c cube. What is minus c cube? Minus c whole cube means minus c into minus c into minus c na. Will agree? 3 times minus is there. Minus into minus plus, plus into minus is again a minus. C into c into c. C cube. Okay na? Like that here it is minus c cube. Is okay? Yeah. Now observe me. It is a cube plus b cube plus 3ab of. What is a plus b? A plus b. Here. A plus b is a minus. Say it is one equation. In the given condition itself, a plus b means minus c is there. So I take here a plus b as a minus c. And this is minus c cube as usual. It is a cube plus b cube plus minus 3abc is equal to minus c cube. Okay, now here plus into minus, 3abc. Okay, now yeah. Now it is a cube plus b cube plus c cube is equal to 3abc. This minus c cubes comes to this side c cube, and this minus 3ab goes to that side is a plus 3abc. Okay, now that is what we required here. A cube plus b cube plus c cube is equal to 3abc. You see, this formula will often comes while we are solving problems in the trigonometry, in the calculus, in algebraic units like that. At the time it is not needed to write all this one. At the time the master will not go aside from the main part of the solution of the problem. If you are going to teach about this one there, while we are solving the problems in the PU1, like these concepts will coming on and off. It is coming and going, coming and going. While we are solving a set question, many concepts are like that. That is why we have to learn it. Oh, if a plus b plus c is equal to 0, then the condition is a cube plus b cube plus c cube is equal to 3abc. Like that only. Okay, now that is the thing. Next, okay, is it clear? Yeah. Now, just next, sixth one. Observe me there, sixth one. Sixth one. You see, if A is equal to B, if condition, then a condition is there. A plus B by 2 is nothing but that A, and that is nothing but that B. Of course, A is equal to B is there. But both ratios, both terms are equal to sum of their terms by divided by 2. It is also using that many times. Many. You see, we consider a plus b by 2. We consider a plus b by 2. Of course, it is a condition, leave it out. A plus A is equal to B. Here, A, what is B? B is nothing but that A. By 2 as it is. We are taking A plus B by 2. What will be happen? For B, we may use A only. A as it is A. Plus. B is nothing but the condition A. By 2 by 2. Here it is 2A by 2. Okay, na? A plus A is 2A. 2A by 2. 2 cancels, so we get A. So A plus B by 2 is equal to how much? A. And what is that A? A is again B. Okay, na? Observe. So we can conclude that A plus B by 2 is equal to A and is equal to B. Okay, na? With what condition? Where. This is the notation for where or otherwise when, where A is equal to B. Okay, na? This is actually With this condition, we have this result. That is the sixth one. Now, we will go to this one, seventh one. You see, A by alpha is equal to B by beta, then that ratio, that means two ratios. A by alpha is one ratio. If it is equal to another ratio, B by beta, then both are equal to A alpha plus B beta by alpha square plus beta square. It's a very fantastic concept. Please note it well. You see, by taking one example, you see that 1 by 2 is nothing but 3 by 6. 1 by 2 is a ratio, 50%. 1 by 2. That is nothing but 3 by 6. 3 by 6 is also 1 by 2. 3 1, 3 2, 6. Or 5 by 10, or 2 by 4, or 8 by 16, or 7 by 14, like that. For example, I am taking 1 by 2 is equal to 3 by 6. Where 1 is equal to, A is equal to 1, no, alpha is equal to 2, na? B is equal to 3, beta is equal to 6. You see, can we verify that 1 into 2 plus 3 into 6 by 2 square plus 6 square? What will happen by using this formula? Whether it is correct or not, by taking one example, I am going. You see now, here 1 into 2, A alpha, like this, A into alpha, 1 into 2, B into beta, 3 into 6. Okay, now like this, 1 into alpha plus B into beta, by alpha square plus beta square. This is 18 plus 2, okay na, by 4 plus 36. That is 20 by 40. That is nothing but 1 by 2. Yeah, correct. So this formula is applicable one. I am here proving this property, not needed. Just to, we have to know the statement of the formula. That is enough. Because in a different way we may prove that is not needed here. By taking one example, I proved that one. So, A alpha plus B beta by alpha square plus beta square is applicable. Okay, Nana? Is okay, na? Like that, we may use the things. Okay, na? Yeah. Now, pass. Okay, Nana? Observe me. 7th is over, now 8th one. 8th also you see, A by B is equal to C by D is given condition. Is given condition. Two ratios are equal, A by B is equal to C by D. Then it is okay, 7th is a different one, 8th see. Then A plus B by A minus B. Here only. Numerator, here I will do A plus B by A minus B, A plus B by A minus B is equal to this side, C plus D by C minus D. Numerator plus denominator by numerator minus denominator. This property is called as the componendo and dividendo method. Observe. See, we are adding 1 on both sides. What will be happened? If I add 1 on both sides, it is A plus B by B is equal to C plus D by D. Okay, na? If I add 1 on both sides, on LHS, RHS, we may subtract with a constant, we may add on both sides with the same constant, we can multiply with a constant, we can divide with a constant. We can raise the index to a constant on both sides, okay, the same constant. Then the values will not be changed. Like that, 1 is added on both sides. So here A by LCM, A plus B by B, okay, na? You know it. C plus D, 1 into D by D. So it is 1. Similarly, on both sides we subtract 1 on both sides. 1 also. So if 1 is subtracted on both sides means it is a minus b by c minus d by d. Okay na? It is a component or it is a dividend. Adding 1 on both sides, subtracting 1 on both sides. Now what is 1 by 2? 1 is, you see, it is a plus b by b by a minus b by b is equal to c plus d by d by c minus d by d. Okay na? You see, observe me. 1 by 2. A plus b by b. A minus b by b. Say, c plus d by d, c minus d by d. LHS by LH. When we divide one equation with another equation means LHS by LHS, RHS by RHS. If we multiply LHS into LHS, RHS into RHS, like that. So here B, B, D, D cancels. Okay na? Now what we will get? A plus B by A minus B. Okay na? A plus B is there, here A minus B is there. Here it is C plus D by C minus D. Okay na? Is okay na? So that is the 8th formula. But with the condition A by B is equal to C by D, then A plus B by A minus B is equal to C plus D by C minus D. Numerator plus numerator by numerator minus numerator. Here also RHS. Numerator plus denominator by numerator minus denominator. Denominator. A plus B, numerator plus denominator by numerator minus denominator. On both sides. Or otherwise, we may use A minus B by A plus B also. C minus D by C plus D also we may use. According to the situation of the problem. What we are asked in the problem, like that, we may use plus by minus on both sides or minus by plus. Both are called as a component dividend method. Yeah. And the last one. Here it is very simple. You see, observe me, I will tell it. The 9th one. You see, the concept of 9 is taking common in the terms. Suppose 5x plus 10xy is there. What is the common in the terms? Here 5x is there, there 10xy is there. In the both terms x is common and 5 is also common. Means if you take 5x as common, there remained only one 5x is there, 1. But here in 10, 5 is taken as common means 2, not 5. 5 2 is 10. Y remained there. Okay na? You see 5x into 1, 5x. 5x into 2, 10x into y as it is. Okay na? That is common, we know it. Suppose it is okay. xy plus z is there. This is z. xy plus z is there. Is there any common? Common is there? No, common is not there. You see. But here x is common. X is there in the first term, but here x is not there. But we may take as x as a common, y plus z by x. Of course, it is a simple concept. How it is possible? X into y is xy. X into z by x. X cancels, we get z. How, sir? It is a problem. It is a doubt for some students. You see, xy plus, we need x by x. xz by x. Can you write it as like that? X into z by x. We are multiplying or dividing. Now you take x as common here. Here y is remained here. After taking x as common, z by x will be there. Okay, now like that we can. Similarly, you see here also. In this term, x is not always there. In the two terms, x is not there. But we may take x as common. That means, you see, observe me. Here x into a by x plus x into b by x. Now you take x as common, then it is a by x plus b by x. Here in the two terms x is common. Here only in one term x is common. Okay, now here x is not common in the two terms, but we may take as a common like this. Okay, is it clear? Yeah. And the last concept, observe it. The last concept. 10 by 7. Divide 10 with 7. Yeah, sum. A simple concept. 10 is called as a dividend. 7 is called by which number we are dividing the given number. That is divisor. And the answer 10 by 7. One time it divides. And the remainder is 3. That one is a quotient. But here this 10 by 7 can be written as like this. That means quotient plus remainder by divisor. Quotient, this is a quotient, it is Q, divisor it is R, remainder, divisor is D, like this. Okay, now. So any number, if it is divided by one number, quotient plus remainder by divisor. You know it, many of you can understand it. Okay, now. Like this, all these our previous concepts we are now recalling it. Is it clear? Okay, now? Yeah. Bye, Nana. Bye.